The Burj Khalifa stands 828 meters over Dubai, and for over a decade, no other building on Earth has come close. Now picture something 173 meters taller than that, rising not out of glass and money in the desert, but out of a folk tale. 3 twisting blades of steel and concrete named after 1001 nights, built for 7,000 people to live inside a single tower. The Council on Tall Buildings' own database still lists it, quietly, under one word, proposed. This is Burj Mubarak Al Kabir. And in over 18 years since it was first drawn, the ground it's supposed to stand on has never once been broken. Kuwait sits on some of the largest proven oil reserves on the planet, and that has always been both its fortune and its problem. Oil revenue built the country, but it also left it exposed, tied to a resource that will not last forever and a price that swings with every geopolitical headline. By the mid-2000s, the government wanted a different kind of headline, not an oil well, but a skyline. The client was the Kuwaiti government itself, working through a private sector partnership led by the Tamdeen Group, and the architect brought in to draw the vision was Eric Kuhn, an American designer known less for engineering bravado than for storytelling, shopping centers, waterfront gardens, the Titanic Museum in Belfast. His brief for Kuwait wasn't a tower. It was a city. 250 square kilometers of it, called Madinat Al-Hareer, the City of Silk, meant to house 700,000 people on a strip of desert north of Kuwait City called Subiyat. The tower was supposed to be the signature, the one image that would make the rest of the world stop and look. Not because Kuwait needed the office space. Because Kuwait needed the headline. And by any measure, the numbers earned the attention. 1,001 meters. The number itself is not an engineering coincidence, it's a nod to the folktale of Scheherazade, 1001 Nights, and to a design language pulled from desert plant life, tapering the way tall grass narrows toward its tip. 234 floors. 7 distinct vertical villages stacked on top of each other, each with its own hotels, apartments, offices, and public space, connected by double-decker elevator cars so the building can move thousands of people through itself without every lift stopping on every floor. Around the tower, Silk City was drawn to include an international airport, a duty-free trade zone, resorts, an athletic academy, and Mubarak Al Kabir port on the bay. The entire package priced, over its projected 25-year build-out, at somewhere north of $130 billion. For a country of roughly 4.5 million people, that is not a building project. That is a bet on an entirely new economy. And then the engineers started doing the math. Because a tower 173 meters taller than the tallest building humans have ever completed does not just need a taller elevator shaft. It needs physics that nobody has been forced to solve at this scale before. In a normal building, say, anything under 400 meters, wind is mostly a nuisance. Engineers design for it, add some stiffness, move on. The moment you push past 6, 7, 800 meters, everything changes, because you are no longer just fighting wind pressure. You are fighting vortex shedding, the technical term for what happens when wind flows around a tall, narrow object and peels off in alternating swirls on either side, like water breaking around a bridge pier. Those swirls don't hit the building evenly. They push, then release, then push from the other side, over and over, and if the rhythm of that push happens to match the building's own natural sway frequency, the structure doesn't just bend. It resonates. It starts swinging harder with every gust instead of settling down. Think about what that means for a moment, a kilometer of steel and concrete, breathing in time with the wind, and nobody wanting it to breathe too well. That's not a hypothetical. It's the reason the world's tallest buildings are almost never simple rectangles anymore, the reason the Burj Khalifa tapers and sets back as it climbs, the reason Taipei 101 hides an 800-ton steel ball near its top just to counteract sway. Burj Mubarak Al Kabir's answer to the same problem was more radical than either of those. Instead of one tower fighting the wind alone, the design splits into three separate, interlocking blades, three towers twisted together around a shared core, with open space between them. Wind doesn't just hit a flat face and bounce off. It passes through the gaps, breaking up the vortex pattern before it can build into a rhythm the structure has to fight. On paper, it's an elegant solution. It's also one that has never been tested at a kilometer above the ground, because nothing built by humans has ever stood there. The firm brought in to turn that idea into calculable engineering was Atkins, the same firm behind the sail-shaped Burj Al Arab down the coast in Dubai, a company with real experience translating dramatic form into something a crane crew can actually pour and bolt together. Their brief was to make the three-blade, tapering form withstand wind speeds up to roughly 241 kilometers an hour, a design threshold well beyond what the Gulf typically sees, built in as a margin rather than an expectation. Each of the three blades terminates at a different height, so the building doesn't present one uniform silhouette to the wind at any single elevation, a detail borrowed from the same logic that makes wind turbine blades uneven lengths to avoid harmonic resonance across a whole field. Inside, the 7 vertical villages are served by those double-decker elevator cars, loading 2 floors simultaneously, cutting down the number of shafts needed to move 7,000 residents and workers through 234 stories without half the building's footprint disappearing into elevator banks. What the public record doesn't show is which alternative forms, a single tapering spire, maybe, or a 2-tower pair, were tested and set aside before the 3-blade version won out. Atkins hasn't published that comparison, and neither has Kuhn's office. That's not a scandal. It's just a gap in what's public, and it's worth being honest about that rather than pretending the process is fully documented when it isn't. But here's something about this building that nobody ever explains, and it has nothing to do with wind. It's plumbing. Pumping water to the 234th floor isn't like pumping it to the 4th. Standard water pressure can't push liquid a kilometer straight up without either bursting the pipes at the bottom or arriving as a trickle at the top, so buildings this tall are broken into pressure zones, essentially stacked buildings within the building, each with its own tanks and pumps, refilling in relay, floor by floor, so nobody above the 150th floor is depending on a single pump at street level not failing. That part doesn't make it into the architecture magazines. Neither does the sand. Subiya sits on the open desert coast of Kuwait Bay, which means the tower's mechanical systems, cooling towers, air intakes, the machinery that keeps a building this size breathable, have to be engineered against fine airborne dust that clogs filtration and abrades glass and steel over years, not months. And then there's the elevator math again, from a different angle, even with double-decker cars, moving 7,000 people out of a single structure during something as routine as a fire drill, let alone an actual evacuation, means the building's exit strategy has to assume not everyone can use the stairs, because at that height, the stairs themselves become the emergency. None of this is exotic to super tall design, honestly, genuinely interesting rather than alarming. Every kilometer-class proposal on the drawing board right now is solving the same 3 problems: water, dust, evacuation, quietly, and engineering reports almost nobody outside the industry ever reads. There is a dated moment in this project's history worth sitting with, and it isn't a structural one. In 2008, with the design finalized and Kuhn's renderings circulating in the international press, reports named a groundbreaking date, February 2009, with the tower itself complete by December 2014. Within weeks of those reports, Lehman Brothers collapsed. By October 2008, global credit markets had effectively seized. By early 2009, the month the tower was supposed to break ground, oil prices, the entire financial backbone of the project, had fallen by more than 2/3 from their summer 2008 peak. Nobody was hurt. No crane fell, no beam cracked, because none had been placed yet. The only thing that came down was the financing environment the whole plan had been built on, and it came down fast enough that the February groundbreaking simply never happened, quietly, without an announcement, the way plans die when nobody wants to be the one to say it out loud. Kuwait wasn't the only Gulf state chasing the kilometer mark. Saudi Arabia announced Jeddah Tower in 2011, also designed to break 1,000 meters, engineered by the same firm that solved Burj Khalifa's wind problem, Skidmore, Owings and Merrill. Jeddah Tower actually broke ground. It rose past 60 stories before construction stopped in 2018 amid funding disputes, and it still sits unfinished, a concrete core rising out of the desert with cranes that haven't moved in years. Here's the thing about kilometer-scale towers that every structural engineer in this space quietly knows: getting the design approved is the easy part. Burj Khalifa is the only one of these three that actually exists, and it exists because Dubai kept paying for it even after the 2008 crash nearly killed it too. Burj Mubarak Al Kabir never got that far. It never got a crane on site at all. But here's the question that sits beneath all of this, the part that has nothing to do with financing and everything to do with physics. There is no historical data for what a kilometer-tall building looks like at 50 years old, because no building on Earth has reached a kilometer, full stop. Burj Khalifa, the current record holder at 828 meters, opened in January 2010. By 2026, it has stood for 16 years, not even old enough to need its first major structural recertification under most international codes, let alone give engineers a picture of what concrete creep, steel fatigue, and wind cycling look like on a super-tall building across 5 decades. If Burj Mubarak Al Kabir is ever built, it would be the first structure of its kind, at its height, anywhere. Not slightly. Not as a design flourish. The first one to actually cross the line every previous super-tall has stopped short of. That means whichever engineers eventually inspect the tower's foundations and connection nodes at year 50, sometime around 2090, if construction somehow started next year and the tower opened by the mid-2030s, will be working entirely without precedent, reading fatigue data on a structure with no older sibling to compare itself to. There is no super-tall on Earth right now that can tell them what normal aging even looks like at that scale. That's not a flaw in the design. Atkins and Kuhn's office did their job by every standard available to them at the time. It's just a gap that time itself hasn't filled in yet, and won't, for a very long time, assuming it gets filled in at all. Right now, none of that theoretical 50-year inspection matters to the people actually out at Subiyat. The Sheikh Jaber Al Ahmed Al Sabah Causeway, the roughly 36-kilometer bridge built specifically to connect Kuwait City to this stretch of desert, opened to traffic in 2019, and commuters and contractors drive it daily now, crossing open water toward a skyline that, on the Subiyat side, is mostly still sand, construction fencing, and the early infrastructure of Mubarak Al Kabir port. Fishermen still work the shallow water off the causeway pilings, the way they did before any of this was announced. Port workers clock in and out of a facility being built in phases, a genuinely under-construction piece of Silk City, even while the tower at its planned center remains a rendering on a website. Somewhere in a Tamdeen Group office, there is presumably still a file with Kuhn's original drawings in it. The twisting blades, the 7 villages, the folk tale made literal in glass and steel. None of the people driving the causeway home in the evening are thinking about vortex shitting, or 50-year fatigue data, or a groundbreaking that quietly evaporated in early 2009. Somewhere on that causeway tonight, a truck driver hauling steel for the port project will glance north, toward the empty stretch of Subiyat where a kilometer-tall tower is supposed to eventually stand, and think nothing of it at all. Just sand. Just another government project, running on government time. The question nobody's really answered is whether eventually has an expiration date, or whether Burj Mubarak Al Kabir simply stays exactly what it's been since 2008, a perfect drawing, waiting. Drop it below. Do you think this one ever actually gets built? See you in the next one.